Hey, and welcome back to the channel, everybody. Well, this is a bit of a supplement video focusing on that bracket that we've built for our surge motor in the last tutorial. We're going to finish that one off today, guys. So once you have got your bracket built, then you're going to need to fabricate your Merbau hardwood decking. And it doesn't have to be Merbau, it can be any type of hardwood decking. And we're going to talk about how we need to fabricate that particular piece of hardwood timber for our motor to go onto that, and how we line up our holes on the bracket we've just built to line up with our Merbau bracket. So you're going to need, guys, a total of 2,000 millimeters or 2 meters of a hardwood timber decking. This is going to be used to place all of your motors and then anything that's associated with those motors onto, so that it keeps your motors and anything that they connect to completely isolated from our metal frame. Now, I recommend that you select a hardwood decking that is 140 millimeters in width and 20 millimeters in thickness. This is what I use with a lot of success on my motion simulator. Do not go under those specs, guys, or it won't be strong enough. This will cover your front motors, your traction loss motor, your surge motor, and anything that the motor's attached to keep them isolated. This is the surge motor bracket, guys, and let's talk about how we build this now. You can see the 4 holes on the left hand side. That's what attaches to the piece of 75 by 5 by 100 mil plate we've just built on our bracket. And on the right hand side is the motor bolt hole location configuration, and the center larger hole there that the motor shaft comes through to attach to the lever, etc., on the other side of the bracket. And we'll discuss how we line up all of these hole locations very shortly. There's a couple of different methods to go about doing this, and we'll cover that in this video. So this obviously is set up in this way to suit this motor. This is a motor that I purchased from Motion Dynamics here in Australia. It's the ZD1766 for right hand side. You can get these on a left hand side or a right hand side. So if you're going to follow along with exactly what we're doing, you'd need to purchase the 1633R. So if you can't get that particular motor, your motor mount locations are going to be slightly different. We'll talk about that shortly. But as far as the actual mounting onto your metal bracket that we've just built, that's going to be the same. So how do we get those hole locations? You simply get your bracket, okay, sit your Merbau on that plate with the holes, and then through the other side with a Sharpie, just mark where the hole locations are, then drill those holes with an 8mm drill bit, the same as on your metal plate. And you'll place that bracket 25mm in from the edge at the side, 25mm from the edge from the bottom, and then your motor mount holes, make sure your leading hole is 40mm from the edge. And the overall length of this surge motor bracket is 195mm in length. Let's talk about our surge motor. Okay, now this surge motor is different from the ZD1735s. This, guys, is a ZD1633R for right hand side. Mentioned already, from Motion Dynamics here in Australia. And this is what is being used for the rear traction loss, because this runs at 65 RPM over the 45 RPM with the big motors. I wanted faster, snappier response from the surge. This works quite well. It's a little bit smaller than what the other motors are. Everything is a bit smaller. It takes only M6. First thing you'll need to do if you're going to use the Merbau bracket, you will require aftermarket M6 bolts. The bolts that come with this are not long enough to get through our 20mm Merbau and give you anything inside. You'll have to go and buy 3, and you'll only probably get packs of 4 M6 40mm in length bolts. Yes, you will need 40mm long bolts, guys, or they will not protrude through the Merbau enough to get a decent amount of thread actually into the motor. So what I'm doing here, guys, is a little bit redundant, because obviously I've already got the shaft set up off the motor. But I talked about 2 methods of trying to stencil your bolt hole locations. Now, one method, guys, is a measurement method, and I'm going to include a link in the video right now to the original 3 degree of freedom motion sim platform motor setup. And you can follow that tutorial and follow that technique for transferring your bolt hole locations from your motor onto your Merbau bracket quite successfully. Now the other way you can go about doing this is the way I actually did it with this particular motor. I was able to use this particular motor to do this method because it's a much smaller shaft than the large front motors or traction loss motor. Because this has got quite a pointy end of the shaft, I was able to just basically measure back on the Merbau roughly 40 millimeters, so then I knew that I had plenty of clearance for strength from the edge to where my leading motor mount bolts would end up finishing at. You make sure that you have your 140 millimeters marked centrally, so then when you put your motor shaft and when you sit it on your Merbau to put some pressure on it to press in to make an indentation, you're actually doing that to the center of your piece of Merbau bracket. Then all I did, guys, is I simply sat the motor with the shaft sitting and pressing onto the Merbau timber, and I just put some pressure, so I pressed it in to the actual Merbau timber itself. And because that motor shaft has got quite a pointy end, because it actually receives a little bolt with these particular motors, that's what holds the bracket on that these would normally attach to the windscreen wiper motor mount. Because it's got a small quite a prominent tip on the end of this shaft, when you press that firmly into the Merbau timber, it leaves a very significant mark, so you can easily see that. Then you can take a 28 millimeter hole saw, and that is specifically for this particular motor obviously, and that can then be used to then drill out a 28 millimeter size hole that you can then place your motor shaft through. That then enables the motor with the actual mounting hole locations to sit flat on the Merbau. And then what I was able to do, because those little mounting holes that take the M6 bolts that we've just talked about, because they're quite small as well, they will also leave a mark when you put pressure on the motor and press it into the Merbau. They will leave the 3 marks on the Merbau for those bolt hole locations for the motor mount, which you would then drill, in our case, guys, with an M6 size bolt, because that's what size bolt is used to mount this particular motor. Now, obviously the caveat is, guys, that with all of what I've just said, it all revolves around these 1633 ZD motors, ZD1766. If you can't get this particular motor and your motor is slightly different, hopefully in that same minimum of 65 RPM range, you want that, guys, in the motor for the surge axis, then you're going to have to do things slightly different. If your shaft is larger, you'll need a larger hole saw, etc. Okay, now I would suggest the easiest way to get around that is to follow that link that I put in the description for actually measuring motor mount hole locations. That is in the 3 Degree of Freedom motion sim platform that I set up for all of the other ZD1735 motors, the front motors and the traction loss motor. You can follow that same method and that same principle for any motor that you would have doing measurements for getting your motor mount hole locations set up on a piece of timber bracketing, or in fact for metal bracketing, either of those. Now this is how I'm coupling the shaft that goes out, that runs to the surge push-pull rod. Okay, now this was done with an old bearing insert out of one of my large casters that I've used the caster frame for our pivot caster. These were inserts inside the caster wheels. They're a very thick 4 millimeter piece of tube. And what I did, guys, I've cut a length of it. It was cut at 30 millimeters in length. All right, this is M12 rod, okay, for reference, and it fits comfortably inside that tube. All right, so that's for reference. So you've got a 4 millimeter thick tube with an inside diameter of 12 millimeters. All right. Okay, so I can hear your brains ticking over and just thinking, what the hell is going on here? Why has he set this motor up in this way, which is completely different to all the other motors. With the ZD1733, this is a much smaller motor than the ZD1735s. So where that motor shaft actually comes through the Merbau, it doesn't come through very far. It does not come through the Merbau far enough to actually be able to physically put a lever on the actual motor shaft of the ZD1633. So what I've had to do, guys, I've had to use that piece of tube. Okay, I've had to drill that piece of tube. That piece of tube slides over the shaft that protrudes just slightly out of the Merbau. This is actually welded on, guys, before you place this onto the Merbau, just by the by. You do this when the motor is not connected to the Merbau bracketing, obviously, or you'll set your Merbau bracketing on fire. This then just slides straight through your Merbau. But yes, so then that piece of M12, that length of M12 threaded rod is inserted into the actual tube that's welded onto the shaft, and then that M12 threaded rod is also welded onto the tube, into the tube. It protrudes into the tube a little bit. I'll give you the specs for that in a second. It's welded into the tube, and the tube is welded onto the actual motor shaft through those 10mm plug holes. So yeah, your piece of tube, you will need to punch some punch marks on that tube in locations that are diagonally opposite from one another, like I'm showing here. And then you drill them with a 10mm drill bit to get a large enough hole to be able to get some good weld in onto the shaft of the motor here, okay? It's the only way really to fix this, if using this motor with a small shaft that doesn't protrude enough through the actual Merbau. Now what I would recommend is to actually insert the 12mm threaded rod first into the tube, okay? Now that rod itself goes in 10mm up inside that tube first, you can see there. So it finishes with an overall length, guys, of 110mm. So 10mm goes up inside the tube and you'll have 100mm protruding. Weld that in first, okay? Then place the tube with the 10mm holes drilled into it. Place that over your motor shaft after you have put a wire brush on the motor shaft, okay, of the motor. Get it nice and clean first. Make sure there's no grease or oil on that, and then you can start welding. Now when you weld that tube onto that motor shaft, as always, it will 100% skew and it will go off center. Right. So what I did to overcome this, or to get it straight, because you can't avoid this happening, is I had my motor plugged into a battery. All right. So what I would do is through one of the 10mm holes that has been drilled into our piece of tube, I just did a light tack. Okay. Then I would run the motor, and then I could see how much the shaft had actually skewed. With a hammer, I very gently straightened it. Ran my motor until I got the shaft straight again. Not breaking the tack, but just straight again, okay? Then I was able to tack the opposite hole through the tube. I was able to tack that. Then that stops it from being able to skew when you weld it. Then you can weld in earnest, guys. And you need to make sure that you get a good hot weld through those plug holes into the shaft. So what you're aiming to do, guys, you're aiming to get penetration into the shaft, and then you're moving that weld pool so that it then contacts the actual tube itself into the holes, okay? And you're welding from the shaft into your piece of tube and filling that hole that you've drilled in there. Now you need to do this in a way that you're getting a good hot penetrative weld, but you're not overheating the motor, and you'll end up melting electrical components in the motor. So you're gonna have to be patient with this. You're gonna have to do a good hot weld and let it cool down for a while. Turn it around the other side, and on that opposing hole, the opposing plug weld, do the same. Let it cool down. Give it a good 10-15 minutes, then come back and just keep doing that until you fill those holes in and you've welded a good penetrative weld into the shaft and into the tube. And this also takes your potentiometer on the end. Now I achieved that, guys, just with the appropriate M12 nut that fits these. And what I found is I found a bolt that basically sat inside the nut, a little bit of bolt head, right, that basically sat in there, because this takes our potentiometer connection, all right? And then I just welded that bolt in, all right, and then it will just have some Loctite put on the end here after our lever goes on, and our lock nuts go on with our lever. I'll show you that in a second. That just screws on tight once this is all together, and then your potentiometer and our fuel hose that connects this to our potentiometer will go on here. That's how we connect our potentiometer. But going back to here, 10mm holes each side, guys, and then you plug weld really well this sleeve onto your shaft. All right, that's how that works. So here's a look at how the surge motor and the shaft that is placed on the surge motor, how it all couples basically to the potentiometer. That's the push rod. It's a piece of 25 by 25mm box. Okay, there's the lever on there. That's some 30mm wide by 10mm thick flat steel. I've drilled a few different hole locations in that, so then I could experiment with how much range or how much fore and aft movement I actually got from the surge. This is how I've ended up with this setup for a realistic amount of braking surge and accelerating surge. And ultimately the 12mm thread that comes out of our tube here, this ultimately connects the potentiometer via some 10mm fuel hose. Now the 10mm fuel hose that's used for this coupling, it's used for the traction loss coupling, it's used on the front motor couplings to the potentiometers. That is used, guys, because it gives you a little bit of grace, it gives you some flex between your motor components and your potentiometer. It's very hard to get a 100% straight shot. So that gives you a little bit of grace and allows some flex between your hard motor mounts and your potentiometer. Works really well. It's cheap. Guys, a lot of how I've built this motion sim has been with materials that I've already had from surplus metals left over from other jobs. And so while we're on that note, guys, about what I've used, you can see the little bracket set up here that holds the potentiometer. That was just a little bit of straight that I actually cut and then made it into a 90-degree bracket. This is why I've suggested that you get 1000mm or 1 meter of some 30mm by 5mm flat steel, so then you can bend that into some bracketing along the way. You're going to need different bracketing for the front motors, for the potentiometer mounts, etc. And you can use stuff like that, 30mm by 5mm flat steel. It's easy enough to bend a flat piece of that. If you put it in a vise and use a hammer, you can bend that into 90-degree brackets, and you can use that for your bracketing. The only special thing with that piece of bracketing, guys, is that I've cut an elongated hole. You can see there where the potentiometer comes through on the left. I've actually drilled two, I think they were 8mm holes in that bracket, and then just with my angle grinder, I cut between those two 8mm holes to make a long elongated slot, so then you can actually line your potentiometer up. You've got enough room to slide it up or down to get it in alignment. I got it roughly where it needed to be. I knew roughly where it needed to be, and then I just allowed some slotting by cutting out some slotting between two 8mm holes, so then I could actually adjust that potentiometer to be level. Here's an example of how the front motor potentiometer mounts are placed. That's some 30 by 30 angle there with a slot cut in it, and then just some flat steel that comes out, and I've slotted that as well where the potentiometer goes on, so the potentiometer can be moved up and down and left and right to get it aligned. And then the same with the traction loss here, guys. It's lined up straight above the lever, and then that piece of bracketing there, guys, is just a slot's been cut in it, so I can move the potentiometer left and right to get it lined up. And as I mentioned, I am using the 3/8 or 10mm fuel hose as the coupling between potentiometer and hard mounts. Now, because that's got a rather large inside diameter, it will not sleeve over the potentiometer snug enough, so you need to insert 10mm outside diameter hose with a 6mm inside diameter, and that snugly fits over the potentiometer shaft and then over our little bolt at the other end that connects to the motor shaft there. Now I've used some 25mm by 25mm box as my push rod that goes to that piece of Merbau bracket there and connects to a male 12mm tie rod end. I've also got a piece of that bearing tube between the tie rod and the actual box there as a spacer, because that tie rod needs to go in the center of the Merbau for strength. So then it's centrally located as well, pushing the trolley rail. So you have to offset this, because you need to offset that box as close to the actual motor as you can get it. Okay, so then there's not too much flex in that 12mm rod there. Okay, so that's how that's all connected up. I'm going to show you how I've drilled the hole locations, etc. for this box in a second. But that's just how to get that lined up. You need to make sure that's straight. You do need to get that as close as you can. I could have used this 10mm by 30mm flat steel, but it's quite heavy, and it would have just made that a lot heavier. That piece of box is much lighter because it's only 1.6mm thick. That's how to set that up. Now here's the box, all right, that I used. As I said, 25 by 25. This is galvanized. I didn't have to weld this, it's just drilled, so it's okay to use this. Now initially I've put in at the end there, guys, 3 different hole locations for different adjustments. In the end, I've ended up cutting through that at the end, and I only used 2. Now that bolt, guys, is 80mm in length, and that's how long that M12 bolt needs to be. That connects to your Merbau tie rod. And these holes, guys, they're all drilled in the center of your 25. They're M12 size holes, and they're just placed 15mm apart from center to center. Well, that is your lot for today. So until I see you in the next tutorial, you guys stay safe, stay healthy, take it easy out.